So here we are on our next topic, and this is going to be applied really with linear functions. So first we need to review what a proportion is. So when we have proportional relationships, we're talking about something that has a constant rate or ratio. Remember that a ratio is a fraction. It compares two quantities, okay? This is my ratio. Proportion is if the ratio is the same for every pair. Notice I am not talking about rate of change. I just mean a constant rate. One way to find a rate is if we find the unit rate, the amount per one thing. So I would write that down. If we find the unit rate, that's the amount per one unit of each thing. So for a relationship to be proportional, the ratio has to be constant. It's non-proportional if their ratio is not the same everywhere we go. So let's see what that means. So here is a situation. What this says is 1 pound costs $6, 2 pounds cost $12, and so on. So what I can do is I can set this up. I would say it's $6 per pound. That is my unit rate, $6 per pound, every 1 pound. So what I want to do is I want to see if my next relationship is the same. So if I do 12 over 2, that, if I divide it, it's $6 per pound. When I look at my next one, 18 divided by 3, that also gives me $6 per pound. Finally, 24 over 4, okay, gives me $6 per pound. Since my rate is constant, it's the same throughout, then it is proportional. I need you to understand here, we are not finding the rate of change. We are not finding the slope. This is not rise over run. We're just determining if our input and output is proportional. It has the same rate. So let's look here. This is miles and the cost of our trip. So if we look at this, it's $5.95 for 4 miles. So if I set this up and I find it, that means it's $1.49 per mile. Well, I can do the same thing on my next one. So it's $9.15 for 8 miles. It's $1.14 per mile. Right away, we can stop. It is not proportional. You don't have to go find all the other ones. Once you find that the rates are different, you know that that relationship between miles and money is not proportional. It's not constant, meaning there's not a linear relationship. So let's look at this next one. Okay. 114 words in 3 minutes. So if I want to find my rate, when they ask you to find the rate at which you're reading, that means I'm reading 38 words per minute. You will need a calculator for this concept, ladies and gentlemen. So next I'm going to do 304 words in 8 minutes. Well, I got 38 words per minute. So here's the thing. Since those two are the same, you cannot just assume, yes, proportional. You need to go and test the other two. This one happens to be 38 words per minute. Next, it's 912 and 24. When I find out its rate is 38 words per minute, meaning it's proportional. This takes us back to some 6th grade, even 7th grade skills when we find the unit rate. So what we can say now is that proportional relationships are also known as direct variation. They are interchangeable. Those words you'll hear go back and forth. So when two variables vary directly, we can write that, okay, in y equals kx. The equation's read y varies directly as x. What this means, k, it's the ratio of y to x. It's a ratio, it's a fraction. So k is if I take my y value over my x value. It has a constant of variation. K is my constant of variation. Okay? So let's look at this. We're going to determine if these values represent a direct variation. So basically, we're looking to see if they're proportional. Remember, proportional and direct variation are interchangeable. So then they want you to give the constant and write an equation. Remember, when we just did this on that last page, okay, our equation for anything that varies directly, okay, is y equals kx. So let's look at my first one. If I put 2 over 1, there's y is my 2, x is my 1. Then 4 over 2. That simplifies to 2 over 1. 6 over 3 and 8 over 4. So what we can say is, yes, it represents a direct variation. So the constant of variation is 2. Therefore, my equation is y equals 2x. That's it. Okay? So remember, your constant is your k. Your equation is when you write y equals whatever x. So let's go look. This only happens if they have a direct variation. Okay, so let's take a look at number 5. When we're talking about direct variation, our direct variation should always have a 0, 0. If I haven't spent any time, my feet should remain where it's at. So 0, 0, if you were to set this up, that's not a rate. Okay, it's the amount per 1. So 0, 0 should always kind of be like your springboard. So when we go look at our altitude to minutes, I have 1,140 divided by 3 is 380. 2,660 divided by 7 is 380. And 3,800 divided by 10 is 380. So if you look at this, they're in proportion to each other, meaning, okay, my constant of variation is 380. So I would replace k with 380, and there is my equation. So I want you, on number 6, to determine if it represents a direct variation. If it does, give the constant and write the equation. This might seem confusing, but if you're confused, go back, rewatch it. We're going to build on this.